In this video, I will show you how to print the reverse value of the given number using loops. So first I will open the editor and creating a new file. Include the required header files. As usual, the standard header file, that is standard input output header file, is required for all programs that I am adding here. Next, begin the main method and next. So we want to read a number from the user, which number we want to reverse. So that is n of type integer, and we are providing a message to the user to enter an integer number. Enter an integer. Just I'm applying new line. After this message, the cursor will be displayed in the next line, waiting for input value from the user. So how do we pass input value using scanf function? Here it is the integer data type, so we have to use the format specifier as %d, and our input variable name is n, so ampersand n. This is so whatever the value that is entered at runtime, that is going to be assigned to the variable n here. And we need a few more variables also. Along with n, we need two more variables. One is to store the remainder. Another one is after printing the reverse number, we need to display it in one variable. So that variable I am taking it here as rev, and initially that is registered with 0. These are the initial requirements. To store the remainder, I declared a variable r, and to store the final output, that is called reverse of the given number, that I am going to store in rev. Initially that holds 0, that is initially with 0. Now just I am adding a condition in while loop. While the given number is above 0, then do the following. First I am trying to calculate the remainder when I am divided with 10. So I using modulus operator percentage symbol, n modulus 10 returns the remainder, that is holded in r. And after that, rev is equals to rev multiplied with 10 plus the above remainder, we are going to add it. The above remainder. This is one thing. And after that, we are each time we are going to divide it with 10. So why we are doing these three lines? What is the use of performing these three, executing these three instructions? Why we kept inside the loops? That I will explain. Now once we come out of the loop, the rev variable holds the final output, that is nothing but reverse of the given number. Once we come out of this loop, so outside of the loop we have to print reverse of the given number %d. So that is held in which variable? rev. rev holds the final output. Final output is nothing but, according to our aim of the program, it is reverse of the given number. So what I done, just I have declared three variables and I initialized only one variable. For n, I am taking the value at runtime with the help of scanf function, and for r, inside the while loop I am assigning some number, and rev initially it is 0, but later it is keep on changing, and n value also keep on changing, and every time we are checking whether n is holding the greater than 0 value or not. Now how these three lines of code will be helpful to print the reverse of the given number, I will show you. I have a document, I will open that one. You can see here. So whatever the logic I typed in that editor, the same logic just I provided here also for a better understanding purpose. Assume that initially I passed 123 as my input value for the input variable n. So what is the n value here? 123. Now initially rev is equals to 0. rev is equals to 0. Remember these two. These two are the initial values of n and r. N and rev. Rev initial value is 0. N value is 123. I assign at runtime. Now, according to this logic, so now the control flow of execution will come to the while loop. So what is the purpose of loop? Loops are helpful to repeatedly execute the same set of statements some number of times or multiple times. If you want to execute the same set of statements again and again, then we can take the help of the loops. So while is one kind of a loop that is used to execute the multiple times. Now, if the entered number is greater than 0 or not, yes, 123 is greater than 0. If 123 is greater than 0, then the control will move inside the while loop. Now, inside the while loop means according to this loop, that is our first iteration. You can see here. I will also highlight here. This is my first iteration. Why? Because 123 is greater than 0. So I'm checking. Now I moved inside the while loop. Now what is R? R is nothing but n modulus 10. N modulus 10 means in the first iteration, what is the n value? 123. 123 modulus 10. 123 modulus 10 means 10 12 is 120. So 123 minus 120, remainder is 3. So R holds the value 3. Now, what is the next step? Next step is REV is equals to REV multiplied by 10 plus R. What is the initial value of REV? Initial value of REV is 0 at this time. In first iteration, REV initialized with 0. So 0 multiplied with any number results 0 plus above R value. What is the above R value? Just now we calculated R is equals to 3. So that value, that is called 3. So finally 0 plus 3 returns 3. So now what is the value that is holded by REV in first iteration? 3. Initially at the beginning we assigned REV is equals to 0, but in first iteration REV value updated with 3. Now what is the next step? N is equals to n division 10. N division 10. So n division 10 means 123 is our original value. At this first iteration, n value is still 123. 123 division 10 means 10 12s are. Means it returns the quotient. So 12 is holded by n. Now, after this statement, the execution flow will move from this place to again from here. Again here. The execution will flow come from this last statement to again while condition. It will check it. What is the latest value of n? 12. Now it will check is 12 is greater than 0 or not. Yes, 12 is still greater than 0. So again condition satisfied. So it enters into the second iteration. If you want, I will increase the font. Second iteration. Now, what is R? Our R is n modulus 10. N modulus 10 means what is n value? 12 modulus 10. So 10 ones are 10. 12 minus 10 results 2. So now latest value of the R is R holds the remainder 2. Now what is the next one? REV is equals to REV multiplied by 10. Initially REV is 0, but late in first iteration REV value becomes 12. REV value becomes 12. Next. So, sorry, 3. 3 means how it becomes 32. 3 multiplied by 10. REV is 3. 3 multiplied by 10 plus latest value of R, that is 32. Now n is equals to n division 10. What is the latest n value in this second iteration? 12. 12 division 10. So 10 ones are 10. So here we are focusing on quotient. So n is equals to 1. Now again n is equals to 1 means again the control will move back from this location to again this while loop. Now it will check is 1 is, what is the latest value of n? 1. Is 1 is greater than 0? Yes, 1 is above 0 only. So again condition becomes for true. So third iteration will start. Third iteration will start. Now inside what is the first statement? R is equals to n modulus 10. N is 1. 1 modulus 10, that is equals to 1. How it becomes 1? 10 0 0. Remainder is 1. So R holds the remainder value 1. Now REV is equals to REV multiplied by 10. The previous iteration REV value is 32. So 32 multiplied by 10 plus latest R value is 1. So this becomes 321. Now n is equals to n division 10. N value is 1. 1 division 10. So 10 zeros are 0 and remainder is 1. So here focusing on quotient. Quotient value is 0. Now when n is equals to 0, again the control will move from this location to this location to again this one. Now is 0 is greater than 0? No. 0 is equals to 0. So now our condition becomes false. Once our condition becomes false, it will come out of the loop. Condition becomes false, it will come out of the loop. Once it come out of the loop, what we are trying to print? We are trying to print the result of the value that is holded by this REV. This REV. This one we are trying to print once it come out of the loop. At the end, what is the value that is holded by REV that we are going to print? Just I will open the program once, you can understand. After come out of the loop, I am trying to print this one. I am trying to print this one now. So I need to save this program to run this one. So now currently I am in CLab directory. So this is a reverse number program. So reverse number dot c. To compile this program, we can click on this icon for compilation. So we found 0 errors and 0 warnings. So successfully compiled. Try to run this program. To run this program, we have to click on this icon, or you have to press F10 button in your keyboard. According to the tracing example, I given 123, so I will take the same example again. Now if you observe, input is 123, reverse of the given number is 321. I will change the input also. Suppose if I given a lengthy number 54321, then it prints 1 2 3 4 5. Any number for any digit it will work. So like this we can print the reverse of the given number. So remember this logic. So why we included r is equals to this one, and this much, why we are holding the reverse value, and why each time we are dividing. So indirectly we are using our decimal number system. That's the reason we are multiplying with 10. Suppose 123, how it forms? 100 plus 20 plus 3. Initially we are multiplied with 1, later we multiplied with 10, later we are multiplied with 100. That is nothing but 10 square, 10 power 1, 10 power 0. So using the same logic we are trying, and each time we are trying to capture the individual digits. How can you capture the individual digits? By applying modulus operator. Indirectly we are capturing the last digit in the input number. Suppose 123 is our input. What is the output of r is equals to n modulus 10? 123 modulus 10 means indirectly we are capturing 3. 12 modulus 10, what is the output? 2. 1 modulus 10, what is the output? 10. That means we are catching the individual digits, and on the individual digits we are applying multiplication with 1, multiplication with 10, multiplication with 100, like that.